Large language models, the so-called LLM, are not designed to produce truth. They are designed to produce plausibility. Their task is simple. Given a textual context, calculate which word is statistically most likely to follow. A probability prediction, not an epistemic discovery. And yet the outcome is surprising, because by repeating this gesture billions of times, the models begin to generate texts that not only sound plausible, but also seem to contain the embryo of reasoning. Not because they have access to truth, but because they learn to simulate the form of thought. The question then becomes inevitable. Is scaling enough? If we increase parameters, data, and interactions, can an operational understanding, an advanced form of reasoning, emerge spontaneously? Empirical data seems to suggest so. In the largest models, we observe unexpected phenomena: arithmetic reasoning, zero-shot translations, coherent inferential chains, as if once a critical threshold is crossed, unforeseen cognitive properties emerge out of pure linguistic statistics. So how can it be? And here physics offers us a powerful analogy. From the chaotic collisions of particles described in Boltzmann, the ordered laws of thermodynamics emerge. In the same way, from billions of linguistic correlations, semantic regularities can emerge that begin to resemble reasoning. A bottom-up process, not a coded top-down. But beware, plausibility, as I said before, is not truth. A model can elegantly describe a unicorn, but that does not make it real. To transform an LLM into a true epistemic engine, something more is required: grounding in the world. Today, a step in this direction is already underway. Models are no longer purely textual. They are multimodal. They look at images, listen to sounds, interpret videos. In this sense, they are already connected to the world, but indirectly, mediated by digital representations, the digital representations that we provide, of course. They see reality as if through a glass. Powerful, yes, but still filtered. The real leap lies in the LLM-based agents. What happens here? The model does not just generate text. It uses external tools. It queries scientific databases and scientific literature. It performs calculations, mathematical, inferential calculations. It plans sequences of actions to achieve a goal. Agents introduce memory, tools, and objectives. They are capable of verifying, correcting, and justifying their answers. In this sense, they are all, we can say they are the first embryos of epistemic agents. Apprentice scientists taking their first steps in the method of knowledge. But we are only at the beginning. These systems still do not experiment, they do not falsify, do not autonomously generate new knowledge. They remain prisoners of the sources we connect them to and of the digital representations that we provide. And yet, the direction is quite clear. Scaling procedures, increasingly refined plausibility. Multimodality enables indirect contact with the world. Agents introduce cycles of verification and action. The day we succeed in integrating these levels into a single system, right? So scale, multimodality, epistemic agency. We may no longer have just language generators, but the first true engines, the first true engines of knowledge, systems capable of participating in the scientific process and the knowledge generation, and not just systems that merely, imitates it.